Okay, Unit 3, Lesson 3 ought to be a little quicker than the last one. We are going to use the product and quotient rules for radicals, which I have mentioned quite a bit, but now we're going to explicitly define and show that they apply for all radicals, not just square roots. And we are going to simplify radical expressions. So, without further ado, let's get to it. Here are the product and quotient rules listed for us here. First, let's look at the product rule, and we'll do a couple of examples right underneath it. If you've got the nth root of a and the nth root of b, that's what we have right here. Let me highlight that because I know that can sometimes show up pretty fuzzy on these videos. If you've got the nth root of a and the nth root of b, and they're both real numbers, and you want to multiply them, then the product rule says, well, you can combine that into one radical, right? The nth root of whatever a times b is. So, for instance, let's just look at some really simple ones to start with. Like if we have the square root of 3 times the square root of 5, which of course we've done stuff like this before, but we're just saying this means we can say the square root of 3 times 5, which of course is the square root of 15, with my terrible handwriting there. Let's look at one that's a little bit more interesting. Let's say you had the cube root of 4 times the cube root of 2, and here's where this becomes really handy. The cube root of 4 is a ridiculous number. It's not rational. It goes on forever. So is the cube root of 2. Those are both irrational numbers. But if we use the product rule here, the cube root of 4 times 2, well, 4 times 2 is 8. And we know what the cube root of 8 is. It's exactly 2. So that's where it's kind of cool. The cube root of 4 and the cube root of 2 individually are irrational numbers, but if you multiply them together, you get a rational number. You get an integer even. Kind of fascinating, really. How about one that looks ridiculous? I don't want to make it too ridiculous. Hello. Whoa, what just happened? I do not know what just happened. Let's get out of that. I apologize. Okay. So, we've got a bunch of stuff going on here. The fourth root of 5x squared times the fourth root of 2y cubed equals, well, we know it's going to be the fourth root of something. 5 times 2 is 10. X squared y to the third. And in this case, I realized that you could simplify the fourth root of x squared, but it's really more trouble than it's worth. So we're just going to leave our answer in this format, because then we'd have to pull the x out and it'd be under a different radical, and that would just be silly. So that's your basic idea there. We'll look at some simplifying some in a few seconds here that maybe are slightly more complicated. But now let's look at quotient rule. In the same way as product rule worked, if we have the nth root of a and the nth root of b, and they're both real numbers, and it's important also that the nth root of b is not 0, because we can't have 0 on the bottom of a fraction. But you see the formula here for the equation. I'll just box it in there. The nth root of a over b can be split up, and you can say, well, that's the nth root of a divided by the nth root of b, or vice versa. And sometimes it's really useful to go the other direction, to go from here to here, to have it split up and then combine it. And let's look at several examples of that again. So we're saying, like, for instance, let me get rid of my arrow over here, bonus arrow. The square root of 25 49ths. Well, what we're saying is, very simply, well, that's the square root of 25 over the square root of 49. We can split it up like that. And we know that that is 5 over 7. Because the square root of 25 is 5, the square root of 49 is 7, so our answer is 5/7. Ta-da! Square root of x over 9. Now this one, square root of x, that's all well and good. We can't really do anything with that because we don't know what x is. But the square root of 9 is 3. So we can split it up like that, where we pull them apart and we can only reduce half of it, but that's fine. We reduced what we could, and there's our answer. Of course, this also applies for cube roots. If I've got the, let's say I have the cube root of 27 over 2y to the 6th. Well, this would be equal to, well, you know what the cube root of 27 is, hopefully, over the cube root of 2y to the 6th. Well, this is equal to 3 over, cube root of 27 is 3, right? Now, the cube root of 2, we can't really do anything with that. The cube root of 2, that's not going to simplify. But the cube root of y to the 6th, let me just write it under here. Remember from the last section, you can think of that as y to the 6th to the 1/3. Well, that's just y squared. So we have a y squared out here. And that's our final answer. 3 over the cube root of 2 times, remember if I don't put a symbol there, there's times y squared. Crazy. Crazy, crazy. I told you sometimes it's useful to go the other direction, so let me give you one more example here before we move on to simplifying. The square root of 75 divided by the square root of 3. Now, well, let me kind of squeeze that in too close there, so let me erase this from the last step. The square root of 75, again, not a number that we know. It's not a rational number. Neither is the square root of 3. But we can combine these. We can use the quotient rule in reverse and say, well, this is the same thing as the square root of 75 over 3. And 75 over 3 is 25. And now we have an answer. How wonderful. Square root of 25 is just 5. So you see we can use it going both directions. We can split them apart and we can pull them back together. Okay. Now the second, that's the first objective. The first objective was using the product and quotient rule for radicals. Now we want to simplify radical expressions. Let me give myself a little bit more space. So, let's do it in red, because that always makes people anxious. Let's say, for instance, you have the square root of 50. When we say simplify this, we mean we want to factor it and break it down and see if we can get some smaller numbers out of this thing. The square root of 50 is not a rational number either, right? Because the square root of 49 is 7, so we know it's a little bit more than 7. But it's certainly not a rational number. However, we can factor it in such a way that we can pull parts out. When we're doing this, your important numbers you're looking for are your perfect squares. That's what you're going to be really interested in. And so hopefully you know what I mean when I say perfect squares. But I'm talking about 1. Let me just list them over here. 1, 4, 9, 16, 25, 36, 49, 64, 81, ... You know, goes on and on forever. Now, if we were in class right now, I would ask you all, what do these numbers all have in common? Well, what they have in common is that they have a square root that is a whole number. Right? The square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, and so on and so forth. Well, the reason these are such valuable numbers here is because if we have one of these numbers that is a factor of, let me switch colors again, if one of these numbers is a factor of this number under the square root, then that means we can pull part of it out. We can simplify it in that way. Now, hopefully, you see pretty clearly which number is a factor of 50. It's 25. 25 will go into 50, right? So think about it this way. I can rewrite 50 as the square root of, well, 50 is just 25 times 2. But we know from product rule now that we can split this apart. So we can think about this as, let me lose my arrow because it's really in my way at this point. We can split this apart and think about it as the square root of 25 times the square root of 2. And we know the square root of 25. So this becomes 5 times the square root of 2. And usually we don't write that times sign, we just put the number right up against the radical. So 5 square root of 2. But know that that means 5 times the square root of 2. Let me do another one. How about the square root of, let me go back to a different color so it'll show up. Square root of 26. Now we're thinking, okay, how can we simplify this? Well, 4 doesn't go into 26, 9 doesn't go into 26, 16, 25, those don't go into 26. 36 is too big, so obviously we can't use that. So this actually cannot be simplified. There's no way to break it down. There's no number we can pull out. So if you're given this and asked to simplify it, you just write, it's the square root of 26. You just write it again in your answer blank. That is your answer. We really can't do anything with that. Just so you have one more example here, let's see if I can come up with one that's a little bit longer. Okay, I had a little interruption there, so I had to pause. Now I got to get back on track. I said I was going to give you one more example, so let me come up with a winner here. The square root of 112. Now, it may not be immediately obvious to you that of what number divides into this, and that's okay. Let's say it wasn't. Let's say because ultimately this number is divisible by 16. But you may not see that right away. Hopefully you would at least see that it's divisible by 4. So let's say I'm going to start with 4 and I'm just going to simplify it that way. Well then 112 can be rewritten as 4 times 28. 28 times 4 is equal to 112, which of course is 2 times the square root of 28, because the square root of 4 is 2. Well, now when I look at this 28, I see, hey, wait a second, I could break that down again, because 28 is divisible by 4. So we just do the process again. So we write the 2 and the square root, and we rewrite 28 as 4 times 7. Now again, if you had realized at the beginning that 16 went into 112, you would have only had to do this one time. But I'm just showing that you don't have to get the biggest one right away. So again, now we simplify. We say, well, I can take the square root of 4, I tried to underline it, and pull it out. So I have 2 times 2 times the square root of 7. I already had a 2 out front. Square root of 4 is another 2. So finally my answer is 4 times the square root of 7. And that would be my final answer. Okay, that should be enough for you to be able to do the Lesson 3 assignment. It's only 11 questions. I don't think it'll take you too long.